So total link performance is given by signal to noise ratio, total, okay, signal to noise ratio -1 is given by signal to noise ratio of the uplink plus signal to interference ratio of the uplink plus signal to noise ratio, noise density ratio, and not is there. So it is signal to, and it's not signal, it's carrier to noise density ratio of downlink plus carrier to interference density ratio of the, sorry, carrier to interference density ratio of the downlink. So this is the total link performance. Total link performance we can calculate by this way. Okay. So this is a total link budget design. Okay. So we will continue with the previous question. In previous question, we have calculated the satellite link where the uplink C by N is given and downlink C by N is given. Now the next question is here. Again, we will consider the system where uplink, okay. So C by N, okay. C by N of uplink was given by 20 dB. Okay, C by N naught of downlink was given as 16 dB. Okay, now the question is now C by I of uplink is given as 23 dB and C by N I of downlink, okay, dear, is given as 20 dB. Okay, so we have to calculate total C by N naught. Okay, so total C by N naught we have to calculate. Okay, so in previous question we have calculated the C by N naught, total C by N naught. Then we will add in that the C by I naught of uplink and C by I naught of the downlink. Okay, so okay, so C by I naught of uplink. So what is this value? This is equivalent to 23 dB and 23 dB is equivalent to 10 to the power 2.3, 23 by 10. So it is equivalent to 199.2. Okay. So C by I -1 भी हम यहीं पे calculate कर लेते हैं. So it is 1 by 199.2 and it is equivalent to 0.005. Okay. Similarly, we will calculate C by I naught. C by I of downlink. Okay. So again, it is given to 20 dB. So 20 dB we have already found out, that is 0.01. Okay. So 20 dB, when we convert it, it will be 100. Okay. And when we consider C by I downlink -1, then it is 0.01. Okay. So total C by N will be, so 10 minute में बात करते हैं class. Okay. So now total क्या हो जाएगा? Total we have already calculated. For that formula we know. So first was C by N of uplink. So that was 0.01 plus C by N of downlink. So that was 0.0251 plus this one C by I of uplink 0.005 plus C by I of downlink, that is 0.01. Okay, so this is total calculation and the value will be C by, this is actually -1, you know? So C by N total -1 is equal to क्या आएगा? पूरा कैलकुलेट करेंगे इन सबको. So it will be around 0.0501. Okay, so C by N of total is 1 by this. Okay, so C by N total is equal to 1 by 0.0501. Okay, so it will be आएगा 19.96. Okay, now we have to convert it into dB. Okay, so dB में कितना आएगा? dB में बताइए. C by N. Okay, so this is carrier to noise ratio. Okay, so now this is carrier to noise ratio. We can find out carrier to noise density ratio. So, okay, carrier to noise ratio is this one. And to calculate carrier to noise density ratio, so there was a formula. किसी को याद है? N naught और N में क्या relation था? N is equal to B into N naught. And last time I have told you. So from here, N naught is equal to N by B. Okay. So to calculate C by N naught, we need bandwidth. Okay. So suppose we can calculate, we can consider bandwidth of suppose 2 megahertz. Okay. B is equal to 2 megahertz. Okay. So to find out C by N naught of total, क्या हो जाएगा? C by N, ठीक है, N naught, in place of N, we are writing N naught. Okay, so it is equivalent to एन नॉट यहाँ पे रिप्लेस करेंगे, सो एन नॉट की क्या हो जाएगा, इट विल बी एन नॉट, ओके, so n by b, so b will go in the numerator, okay. So now total this signal to or carrier to noise ratio, it will be c by, okay, c by n by b, okay, so c by n by b, okay, it will be this one, okay. So कर लीजिए c by n by b, okay, so c by n is 19.96, then by b means b will be multiplied by, तो क्या हो गया, b into c by n of t, okay. So now substitute the value, c by n naught t is equal to, b is your 2 megahertz, so 2 into 10 power 6 into c by n is 19.96, okay, so it will be 39.92 into 10 to the power 6, okay. So we can convert it into dB, that is n naught in dB. So क्या आ जाएगा n naught in dB, 10 log of this, 10 log base 10 and this 39.92 into 10 to the power 6. Okay, so it will be around 76 dB hertz. Okay, so if you have any doubt in this, you can ask.